changes in the members, since there are always births and deaths within a population. Today, we are going to be investigating how do births and deaths in a population affect its size. We will use a model today to help us learn how births and deaths affect a population. Now, in a moment here, you may want to stop this video or pause this video and gather up some on here. So if you could recreate this pretty easily, if you want. Awesome. Glad you're back. Okay, so here's what we're going to do. If you can imagine that these tokens here are organisms, we will, if an organism is born, we will place it into our population, and if an organism dies, we will remove it from our population. When we're done with our token activity here, we are going to make a few line graphs as well. And so that's what you see this graphing portion here for. If you would, make sure that you have the directions in front of you for lesson 2.2, and then you can follow along, and I will work the model activity so that you can get any information you need from it. And so if you look, you'll see there's a first mission there, and that first mission says to make the population stay the same over time. Alright, so our directions say to add 14 tokens to the circle. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oop, I've got an escapee token. 14 tokens. Alright, and we are going to be making the population stay the same size over time. Now, I'm just going to use this same piece of paper, which you may be able to do as well as you work through this activity. Just save yourself some space and maybe switch colors as you go. Alright, so for our first round here, the directions say to every year take 1, 2, or 3 organisms that die and 1, 2, or 3 organisms that must be born. How many is up to you? So I'm going to have 2 organisms die. So I'm going to remove 2 organisms from our population. I'm going to go ahead and record those 2 deaths right here on our table. Alright, and then I'm going to have, say, 3 organisms be born. So here's the 2 that I removed, and here's 1 more. So 3 organisms were born. Now, it asks for the total of organisms. So if we count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is the number that we get. And so that would represent 1 year. And our directions say, repeat until you have modeled 6 years. Alright, so we're just going to keep on adding and killing stuff here. I'm sorry, birthing and deathing organisms. Alright, so let's say for year 2, we're going to have 2 organisms die. So we're going to remove 2 organisms from our population. And we'll say 1 organism is born. And so we're going to add an organism to our population. Now our total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 goes right here. In the following year, we'll say there were 3 deaths. And so we're going to put in a 3. And we'll say there was 1 birth. There's our 1 birth. And so our population total should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, another year goes by, and we'll say there are 2 deaths in our population. Oh, that guy's sliding away on me. And let's see, we'll say there are 3 births. So 2 deaths, and we'll say there's 3 births. So 1, 2, 3 births come on in. Alright, that should give us a new total population. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okie dokie. Year 5 sees 1 death, but it sees 3 births. So we're going to bring in 1, 2, 3 to our population. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in our population now. And now here's the year that's critical, right? Because we were told for mission 1, we have to keep our population the same size over time. So we know our ending number needs to be what we started with, which was 14 organisms. So that means we're going to have 2 deaths, and we're going to have 1 birth. And so that now should give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 organisms. So over the course of time, right, we finished our mission. We made the population stay the same size. Okay, now